Greetings, space enthusiasts and curious minds. Ever pondered about how our solar system originated? Our journey today takes us to the very beginnings of our cosmic neighborhood. We'll be exploring alternative hypotheses surrounding the formation of the solar system. It's a vast and complex topic, teeming with riveting theories that seek to explain the birth of our home in the cosmos. Picture it, our solar system, a majestic dance of celestial bodies, each performing a cosmic ballet around the sun. 8 planets, countless asteroids, comets, and other objects, all bound together by the invisible ties of gravity. But how did this intricate system come into being? What cosmic events led to the creation of our Earth, the red plains of Mars, or the gaseous swirls of Jupiter? The formation of the solar system is a topic that has sparked numerous debates among scientists. It's a puzzle that has yet to be completely solved. The pieces include the sun, planets, moons, and the myriad of smaller objects like asteroids and comets, but how these pieces fit together is a mystery that has given birth to many intriguing theories. Some suggest it all started from a nebulous cloud of dust and gas, collapsing under its own gravity. Others propose that planetesimals, small chunks of rock and ice, gradually came together to form the planets. Yet another theory posits that protoplanets, embryonic worlds, collided and coalesced to give birth to the planets we see today. Each theory carries with it its own unique implications about the early universe and the processes that led to the formation of our solar system. Each hypothesis, no matter how different, attempts to answer the same fundamental question: how did our solar system come into existence? So prepare to embark on a journey of cosmic proportions. We'll delve into the nebular hypothesis, the planetesimal hypothesis, and the protoplanet hypothesis, examining the evidence that supports each one and the questions they still leave unanswered. Do subscribe and comment below about which theory you find most intriguing. Let's dive deep into these fascinating hypotheses. First up, we have the nebular hypothesis, a popular theory that has been around since the 18th century. This theory, as old as it may be, continues to hold sway in our understanding of the universe. At its core, the nebular hypothesis proposes that our solar system originated from a massive, rotating cloud of gas and dust, fondly known as the solar nebula. Picture this, a vast and expansive cloud of cosmic dust and gas, spinning and swirling in the vast expanse of space. Over time, this cloud starts to contract under its own gravity, spinning faster and faster. As it contracts, the cloud flattens into a disk with a bulging center. This bulge, due to the immense pressure and heat, ignites to form what we now know as the sun. But what about the planets? Well, let's dive a little deeper. Surrounding the newborn sun is a disk of remaining gas and dust. In this disk, solid particles start to collide and stick together through a process known as accretion. These tiny solid bits gradually grow larger and larger, forming planetesimals and eventually planets. The inner planets, also known as terrestrial planets like our own Earth, are believed to have formed from the heavier metallic elements that were able to withstand the sun's intense heat. Meanwhile, the gas giants, or the outer planets, formed further away where it was cool enough for lighter gaseous elements to survive. And voila! That in a nutshell is the nebular hypothesis, a cosmic dance of gas, dust, and gravity leading to the birth of our solar system. But remember, as fascinating as it is, this is just one theory among many. Science, after all, is about questioning, exploring, and understanding the world around us. Though widely accepted, the nebular hypothesis isn't the only game in town. So, let's continue our journey and explore other intriguing theories about the formation of our solar system. Next, we explore the planetesimal hypothesis, an offshoot of the nebular theory. This hypothesis takes us into a cosmic dance of matter, gravity, and time, painting a picture of how our solar system could have come into existence. Let's imagine the early solar system as a vast, swirling cloud of gas and dust, the remnants of a nebula. Within this cloud, tiny particles of matter begin to collide and stick together, forming larger bodies of matter. These are the planetesimals, the building blocks of planets. Now here's where things get interesting. The planetesimal hypothesis suggests that these planetesimals, through countless collisions and coalescences, gradually accumulate more and more matter. Over millions of years, these planetesimals grow from mere specks of dust to bodies spanning hundreds of kilometers in diameter. As these planetesimals grow larger, they exert a stronger gravitational pull, drawing in more matter and growing even larger. This is the concept of gravitational instability, a positive feedback loop where the bigger you are, the more you grow. But it's not a peaceful process. The solar system was a violent place in its early days. with planetesimals colliding and merging, growing and evolving. These collisions play a crucial role in the formation of planets as they allow planetesimals to grow larger and eventually form protoplanets. Over time, these protoplanets continue to grow, sweeping up leftover planetesimals in their orbits until they become the planets we know today. It's a tale of growth and survival, of chaos turning into order, told through the lens of the planetesimal hypothesis. But remember, this is just one hypothesis among many, each with its strengths and weaknesses. The planetesimal hypothesis, for example, struggles to explain how these tiny particles of matter stuck together in the first place. But that's a topic for another time. The planetesimal hypothesis adds a fascinating perspective to our solar system's formation, doesn't it? Now let's move on to the protoplanet hypothesis, a theory that refines the previous two. This fascinating hypothesis suggests that our planets didn't just form from tiny dust particles or even larger planetesimals, but from something much bigger, protoplanets. So, what exactly are protoplanets? Well, they're celestial bodies that are larger than planetesimals, and they're believed to be the building blocks of planets. They formed during the early stages of our solar system's formation, when the universe was still a swirling mass of dust and gas. As these materials came together, they began to grow in size, eventually forming these large bodies we now call protoplanets. But how does this growth happen? This is where the concept of runaway growth comes in, a key part of the protoplanet hypothesis. Runaway growth is a process where larger bodies, or protoplanets, have stronger gravitational pulls. This means they can attract more matter, which causes them to grow even larger faster. It's a snowball effect that leads to the formation of planets. However, the protoplanet hypothesis doesn't stop there. It also suggests the formation of a protoplanetary disk. Imagine a flat, circular disk of gas and dust surrounding a young star. This disk is where the magic happens, where the protoplanets start to form. As the protoplanets orbit around the star, they gather more and more material from the disk, growing in size until they become the planets we know today. This hypothesis, while not without its challenges, provides a more detailed picture of our solar system's formation. It takes into account the size and composition of the protoplanets, the process of runaway growth, and the crucial role of the protoplanetary disk. The protoplanet hypothesis brings us one step closer to understanding our solar system's origins. It's a reminder that our universe is a vast, complex place, where even the smallest dust particle can play a role in creating something as enormous and beautiful as a planet. So, there you have it, 3 alternative hypotheses about the formation of our solar system. We've journeyed through the nebular, planetesimal, and protoplanet hypotheses, each one offering its own unique perspective on how our cosmic neighborhood came to be. Firstly, we explored the nebular hypothesis, which suggests that the solar system formed from a giant rotating cloud of gas and dust, the solar nebula. This nebula, under the influence of gravity, collapsed onto itself, forming a spinning disk with the sun at its center, and the planets forming from the remaining material. Next, we delved into the planetesimal hypothesis. This theory proposes that small solid particles clump together to form larger bodies, eventually forming the planets. These planetesimals, as they're called, collided and merged, growing larger over time in a process known as accretion. Lastly, we examined the protoplanet hypothesis, which builds on the planetesimal theory. It suggests that these planetesimals coalesced to form protoplanets, which then went through a period of violent collisions and mergers to form the planets we know today. Each of these theories offers a different lens through which to view the formation of our solar system, and research in this field is ongoing. With the advancement of technology and our increasing ability to observe and understand the universe around us, new theories may yet emerge in the future. In the grand scheme of things, our understanding of the cosmos is still in its infancy. There's so much more to learn, to discover, and to understand. The mysteries of the universe are vast and infinite, and it's up to us, the curious minds, the explorers, the dreamers, to unravel them. We hope this journey through the cosmos has sparked your curiosity. Remember to subscribe and comment with your thoughts on these hypotheses. Until next time, keep exploring the stars.